Welcome to Electronics India YouTube channel. In this lecture, we are going to see about an introduction to fiber optical cable and its classifications. So we all know that an optical fiber is a flexible, transparent fiber made by drawing a glass of material, silica or plastic, to a diameter slightly thicker than that of the human hair. Optical fibers are used most often as a means to transmit light between the two ends of the fiber and find a wide usage in fiber optic communications, where they permit transmission over longer distances and at higher bandwidth than the electrical cables. And the fiber optical cable that consists of three important parts, such as core, cladding, and the third one is outer plastic coating or jacket. Core is a innermost portion of an optical fiber through which the light propagates. It is cylindrical in shape and it is made up of flexible glass of high refractive index. The diameter of the core is the diameter of the core of a single mode fiber is 8 to 10 micrometer, while the multi-mode fibers are 50 micrometer in diameter. It is also called the optical waveguide, since it is the main channel through which the light signals are transmitted. The second important component is cladding. The core is surrounded by a glass called cladding. The glass of cladding has a lower refractive index than the core. This enables the total internal reflection of light waves in the core and eventually propagation of light waves within the core. And the third important element is outer coating or jacket. The outer jacket is a thin plastic sheath or coating that is a it prevents light rays from outside to enter into the optical fiber, and these fibers are usually typically it is bundles together, where each bundle is covered by a protective outer sheath that prevents the fibers from physical damages also. Now we will see the different types of connectors that is used to connect the fiber optical cables. The fiber optical cables need to be connected so that there is no leakage of light signals. There are three important types of connector. The acronyms are SC, LC, FC and ST. It refers to the most common types of optical connectors in different applications and data networks. And let us see the first one, SC connectors. SC stands for subscriber connector. It is a general purpose push-pull type connector. The subscriber connector has an advantage in keyed duplexity to support or send and receive channels, and mostly used in CATV applications. And the second type of connector is called ST connector. ST stands for straight tip, a quick release bayonet style connector with a long ferrule. STs were predominant in the late 80s and 90s, early 90s, and it is the common type of connector for multi-mode multi-mode fibers. And the third type of connector is called FC connector. FC stands for fixed connection. It is fixed by the way of threaded barrel housing. FC connectors are typical in test environments and for single mode applications. FC connectors were designed for use in high vibration environments. And the fourth type of connector called LC connector, loosened connector. The LC is a small form factor connector, much like the ST connector, but with a ferrule that is half the size. Now let us discuss about the different types of fiber optical cables. So normally the fiber optical cables are classified into two categories based on the number of modes and the refractive index. Based on the number of modes, it is classified into single mode fiber and multi-mode fiber. And based on the refractive index, it is classified into step index optical fiber and graded index optical fiber. Let us see one by one. The figure shows the single mode fiber structure of the single mode fiber. The single mode fiber is usually of a wavelength 1310 nanometer to 1550 nanometer. In single mode fiber, only one type of ray of light can propagate through the fiber, and this type of fiber has a very small core diameter and the size of 5 micrometer and a high cladding diameter 70 micrometer, and the difference between the refractive index of core and the cladding is very small. This is a very important point. In case of single mode fiber, the difference between the refractive index of core and cladding is very small, and there is no dispersion, that means no degradation of the signal during the traveling through the fiber, and this light is passed through it through a laser diode. And the second type of classification is called a multi-mode fiber. The wavelength of light waves in multi-mode fiber or in the visible spectrum ranging from 850 nanometer to 1300 nanometer. This multi-mode fiber allows a large number of modes for the light ray traveling through it. The core diameter is generally 40 micrometer and that of cladding is 70 micrometer. The relative refractive index difference is also very greater than that of single mode fiber. There is a signal degradation due to the multi-mode dispersion. It is not suitable for long distance communication due to its large dispersion and attenuation of the signal. There are two categories on the basis of multi-mode fiber. One is called step index fiber and graded index fiber. Basically, these are the categories under the types of optical fiber on the basis of refractive index. So, based on the basis of refractive index, we can classify the fibers into two types: step index and graded index. The figure shows the picture of step index optical fiber. The refractive index of the core is constant in case of step index fiber. The refractive index of the cladding is also constant, and the ray of light propagate through it in the form of meridional rays. In the case of step index fiber, the light propagate through it in the form of meridional rays which cross the fiber axis during every reflection at the core cladding boundary, and attenuation is more for multi-mode step index fiber, but for a single mode fiber it is very less. The fiber has a lower bandwidth. The number of modes of propagation for the single mode fiber is v square by 2, where d represents diameter of the fiber core, lambda represents wavelength, Na represents numerical aperture, and v represents v number. It is less than or equal to 2.405 for single mode fiber and greater than 2.405 for multi-mode fiber. And the last classification, final classification, is graded index optical fiber. In this type of fiber, the core has a uniform refractive index that gradually decreases from the center towards the core cladding interface. The cladding has a uniform refractive index. The light rays propagates through it in the form of skew rays, sometimes called as helical rays. Skew rays are otherwise called as helical rays. It does not cross the fiber axis at any time. The fiber has a much higher bandwidth. The number of modes of propagation for graded index fiber is expressed as v square by 4, where v is equal to 4.9 into d into numerical aperture divided by lambda the whole square divided by 2, where lambda represents wavelength, Na represents numerical aperture. We also have one more expression for number of modes n graded equal to n step divided by 2. So that's all about classifications of optical fiber. Thanks for watching.